Hi, I'm Aaron from Living Science Videos. You know, the purpose of science is to improve understanding. But what if you have two competing explanations for the same observation? How do you tell which one is right and which should be corrected or discarded? Because for many years, people believed some pretty bizarre things. For example, science showed that the world was round thousands of years ago, but many people still believed the earth was flat right through the Middle Ages. They used to think that everything was made of only four elements: earth, air, fire, water, and a fifth element they couldn't always agree on. Around 400 BC, Democritus deduced that real elements should be based on tiny particles called atoms. However, his rival, Aristotle's view of the five elements, was more popular, and atomic theory was forgotten until the 1800s when John Dalton proposed it again. So we see that sometimes people will cling to the wrong answer and promote that forever, even when the right answer is no. And science has changed over the centuries to avoid this exact problem. The scientific method is a process developed to test competing explanations and to make new discoveries about how nature really works. Ideas are subjected to rigorous testing, and those that pass initial tests are subjected to even more testing by other scientists. To illustrate how the scientific method works and how it was devised, let's look at how science dealt with an important question. Where does life come from? In ancient Greece, the earliest philosophers of science had some idea that life may have evolved, but they couldn't even guess how that might have happened. We understand that a lot better now, but knowing how life changes over time does not explain how life began. The origin of life and the evolution of life are completely different processes. In the 15th through 19th centuries, there was a scientific revolution in Europe, an age of reason and enlightenment that led to the formation of modern science. But those pioneers were not the same as the scientists of today. It can be fascinating to read about their work and words because so little was known back then. Their ideas were often way wrong because people of that time commonly believed a lot of really weird things that no one believes anymore. Astronomy replaced astrology, and they began to understand medicine because alchemy was replaced by chemistry, and so on. And before anyone understood chemistry or chemical reactions, people had some very strange ideas about how such things worked. Centuries ago, some pioneer scientists thought that the reason things burned was that they were partly made of an invisible mystery material called phlogiston. They thought that when something burned, this element of fire came out of it, leaving only ashes. There was no evidence to support this. It's just something that someone made up. But once they had that idea in their heads, some of these scientists refused to let it go, even when all their experiments failed. Finally, someone showed what combustion is, the real reason why things burn, and thus proved there's no such thing as phlogiston. Back then, people had some very strange ideas about life, too. For thousands of years, people believed in vitalism. The idea that living things could move and grow because of an animating spirit, that everything that is alive has the spirit of life in it. And we're not talking about an immortal soul that leaves the body when someone dies. This is different. They believed that when anything died, its vital life force was still inside it. They thought that when the physical body rots, the life force in it would go bad too, and that it would slowly ebb out in the form of vile and disgusting organisms. They thought that whenever once living matter decomposes, whether it's a dead animal, rotten vegetables, or even poop, it would spontaneously, magically generate maggots, mold, or mice. In 1620, John Baptista van Helmont discovered mice living in a jar of wheat and dirty linen, and he concluded that mice were magically spawned out of moldy wheat mixed with human sweat. Why didn't he think it more likely that mice had just moved into that jar because there's comfy bedding and food there? Well, just remember, this is coming from a guy who stores his dirty underwear in a jar full of wheat. In 1668, Francisco Redi performed one of the first ever scientific experiments attempting to disprove spontaneous generation. He guessed that maggots didn't appear on meat by magic, but that flies laid eggs on the meat and their eggs are too small to see. He tested his hypothesis with a number of flasks, some open to the air, some sealed airtight, and some covered by gauze or cheesecloth. As expected, the maggots only appeared on the open jars where flies could get to the meat. That first experiment didn't convince everyone because the invention of magnifying lenses led to the discovery of microscopic organisms. So people still believed that if they let food rot in water, it would spontaneously generate microbes, which they then called animalcules. A Catholic priest named John Needham claimed to have proved this in 1745. He boiled chicken broth to kill any microbes inside, and then poured it into a flask and let it sit until new microbes seemed to appear out of nowhere. In 1768, another priest named Lazzaro Spallanzani claimed to have disproved the same idea with the same experiment, but this time the broth was boiled in a vacuum-sealed container where nothing could get in. However, his critics said that all Spallanzani proved was that life couldn't spontaneously generate without access to the vital force, which they believed to be floating around in the air. Finally, in 1859, the French chemist Louis Pasteur performed a conclusive experiment that even spontaneous generation believers couldn't deny. He boiled chicken broth in special flasks with an S-shape or swan-necked spout. If there was any vital force in the air, it could get in, but microbes riding on airborne dust particles would be trapped in the bottom due to gravity. Normal flasks, where dust could settle in the broth, developed microbes very quickly. But nothing grew in the special flasks even after a whole year. Once Pasteur broke the neck of a flask, or tipped it such that the broth could reach the trap, then it would fill with microbes too. Pasteur was successful because he used the scientific method and used a carefully designed experiment to disprove spontaneous generation. He understood the question. He researched what was known about it up to that point. He formed a testable hypothesis, conducted his experiment to record the data, and drew his conclusion. And in 1861, he submitted his study for peer review. Now, his experiment proved that living microbes were abundant even in the air. He also disproved spontaneous generation because he showed that life did not arise from the dead remains of old life, but by contamination from continuing life. And this led Pasteur to invent the law of biogenesis, saying that life only comes from life. But is it always that simple? Contrary to popular interpretation, no experiment ever proved that there's no possible way for life to begin, nor that life could never emerge from complex chemicals that didn't qualify as life before. In 1855, medical doctor Rudolf Virchow, the father of modern pathology, argued that the formation of life had to come from a prior matrix. In other words, living cells had to originate from earlier cells. He also said that diseased cells were caused by other diseased cells, and he said that understanding that this chain reaction had to begin with a first cell that wasn't diseased already, but became so. So maybe the first living cells came from cells that didn't yet meet all the criteria required to qualify as alive. Later scientists discussed the various ways in which the very first cells may have formed through an intricate multi-stage process. In 1870, Thomas Huxley called this idea abiogenesis, and he remarked that spontaneous generation and abiogenesis were often confused with each other, and if you look in common dictionaries today, you'll see that they still are. They come from the same source and both address the same question, but they are not the same answer. They are two very different hypotheses. Hypotheses have to be testable, because if it can't be confirmed or corrected, then it does not qualify as knowledge. So one of the principal rules of science is that it can only examine natural explanations. Like most scientists of his day, Louis Pasteur eventually accepted that life, including bacteria, had evolved over hundreds of millions of years. Another important scientist at that time was Lord Kelvin, who conceived the laws of thermodynamics. He did not accept evolution. He believed in intelligent design, but he also said in 1871 that if we trace the history of Earth backward, we come to a time when the world was so hot that no life could exist. How then did life originate on the Earth? He said that science is honor-bound to fearlessly face every problem, and if a natural solution can be found, we must not evoke an abnormal act of creative power. The fossil record indicates that for most of the history of life on Earth, about 3 billion years or so, the only living things were single-celled microbes, and before that there was no life at all. The Earth was evidently a dynamic world of complex chemistry, but still a lifeless planet at one time billions of years ago. So, how did life begin? We still don't know. But we have a working hypothesis, the only one currently supported by modern experimental science, and that is abiogenesis. Spontaneous generation was at best a silly misunderstanding. Abiogenesis, however, is an aspect of molecular biology and is so complex that we will have to cover it in another lesson. Thank you for watching.